Yeah, so this is a question from GATE 2016. The question is a continuous time function x of t is periodic with period t. The function is sampled uniformly with the sampling period ts. In which one of the following cases is the sampled signal periodic? So the question is, we have a continuous periodic signal x of t and it is sampled with a sampling period of ts. Right. So let me draw a continuous time signal. So it can be anything. So let me take it as a sinusoid like this. So this is x of t, right? And we know given x of t is periodic with period t. So I can write as x of t is to be equal to x of t plus t. This is same as x of t plus 2t and so on. Or in general, I can write x of t as x of t plus mt, right? Where m can be equal to 0, 1, 2, etc. till infinity, or minus 1, minus 2, so on, right? Now, this is sampled at a sampling period of ts. So let this be the sampled signal. So I'll call it as x of n, right? Or it is sampled at a period of ts, right? Sampling period of ts. So x of t is sampled. So it's actually given as x of n ts, or simply x of n, both are same. Now say x of n is shifted by capital N, by some value capital N, okay, which means I'll write as x of n plus n, or x of nts plus capital Nts, both are same, okay, right? Now for x of n to be periodic with period n, right, this term should be equal to this term, right? So x of n, sampled signal, which is a sampled version of x of t, and this x of t is already having a period t, right, capital T, and this signal should to be periodic with period capital N. For that, what should be, like, mt should be equal to nts. That's obvious, right? So mt should be equal to nt, or we can say like t by ts should be equal to n by m, right? So the sampled signal x of n will be periodic with a period n if this is equal, or n by m is actually a rational number. Okay, so if this is a rational number, then definitely this x of n will be a periodic with period n, capital N, right? So we'll see the option. So given option A, here it is n equal to root 2 ts, or we can say n by m is equal to root 2, right? So n by m is root 2, which is obviously a non-rational number, or not a rational number, which means option A is not correct, right? Now if I take the option B, given the n by m value is equal to 1.2, so definitely it's a rational value, right? So it's a rational number. So 1.2 is same as 12 by 10 or 6 by 5, so it's actually a rational number. So for this case, n by m is rational, so the answer is this is true. So if I sample the signal with this ratio t equal to 1.2 times ts, definitely it's a periodic signal. So the signal is periodic. Yeah, so this is another question from GATE 2016. The question is, consider the sequence x of n equal to a power n u of n plus b power n u of n, where u of n denotes the unit step sequence, and 0 less than mode a less than mode b less than 1. The region of convergence R of c of the z transform of x of n is. So the question is to find the ROC of this term, that is z transform of this term. So given x of n equal to a power n u of n plus b power n u of n. So how to find the z transform of this? We need to find the z transform of this term, and then z transform of this term, and the sum of that. And ROC will be the intersection of ROC between ROC of these two terms, right? So if I take the first term, a power n u of n, the z transform of this term is, we know it is 1 by 1 minus a z inverse, and its ROC is mod z greater than mod a, right? And similarly, the second term, b power n u of n, the z transform of this term is 1 by 1 minus b z inverse, whose ROC is mod z greater than mod b, right? So which means x of z, which corresponds to the z transform of x of n, right? It is given as 1 by 1 minus a z inverse plus 1 by 1 minus b z inverse. And what is the ROC? So it is actually the intersection of ROC between this and this. So we'll just draw the ROC of these two terms, right? So the ROC of first term is mod z greater than a, which is, so if this is a circle A, the region outside the circle, right, this is the ROC of the first ROC, right? Similarly, the second term ROC is similar to this, with the area above the circle with radius b, right? But here given b is greater than a, right? So b is actually greater than a, which means the ROC of the second term will be something like this, right? Its ROC will be the area outside this circle with the circle's radius is b. Now the ROC of x of z, okay, what is the ROC of x of z? It will be intersection between these two. So what is the intersection area? It is actually this area. So both is included, right? This is the intersection of the two ROC. And what is this ROC? ROC is mod z greater than mod b, right? So which means the ROC of x of z is mod z greater than mod b. So answer is B. Yeah, so this is a question from K2016. The question is, a continuous time sinusoid of frequency 33 Hz is multiplied with a periodic Dirac impulse train of frequency 46 Hz. The resulting signal is passed through an ideal analog low-pass filter with a cutoff frequency of 23 Hz. The fundamental frequency of the output is. So question is like, we have a continuous time sinusoid signal like this, okay, and this frequency of this is 33 Hz. So I'll call it as EFM to be equal to 33 Hz, and this is multiplied by Dirac impulse train, right? So it's actually an impulse train. That's it. That is, it will have impulses at like this 0 ts, 2 ts, like that. Okay. So it is multiplied. So if it is multiplied, what I will get? We'll get one sampled signal, right? We'll get a sampled signal of this one. So if it is x of t, this will be the y of t. Okay. And this signal is passed through a low pass filter, and the question is to find the output frequency component at the output of this low pass filter, and given the frequency cutoff frequency of low pass filter fc is given as 23 Hz. So how to find this f0? We need to find what all frequency components are available at this input of low pass filter, or what are the frequency component available at y of t, and what all frequency fy less than fc, that is the cutoff frequency of low pass filter, all these components will be available at f0. Since we have a signal x of t and it is multiplied with, say, this x delta t, we will have a sampled signal, right? So what is the frequency, what all the frequency component available here? So if sampling frequency of this Dirac impulse train, say if it is fs, then the frequency component fy available here will be, is given as y of fy is equal to k into fs, where fs is the sampling frequency here, plus or minus fm. So this will be the frequency component available here, where k is given as, k is 0, it may be 0, 1, 2, etc., or it may be minus 1, minus 2, etc. So it will be values from minus infinity to infinity. We have fs to be equal to 46 Hz, right? 46 Hz. The fm is this one, right? That is 33 Hz. So what all values will be there for what is a value at k equal to 0, right? So at k equal to 0, the component fy will be equal to 0 plus or minus fm, or plus or minus 33 Hz, right? Similarly at k equal to 1, fy will be equal to 1 into f of s, that is 1 into 46 plus or minus 33, right? So this will be either, if it is plus, it will be 79 Hz, or if it is minus, it will be 13 Hz. Okay, either this or this. Now if it is k equal to minus 1, fy will be equal to minus 46 plus or minus 36, sorry, 33. So if it is plus, then it will be minus 13 Hz, right? Or it will be, if it is minus, it will be minus 79 Hz, right? Now if it is k equal to 2, fy is equal to 2 into 46 plus or minus 33, which is either 125 or 59 Hz, right? Similarly is the case for k equal to minus 2, minus 3 plus or minus 3, etc. So as the k value increases, this value increases like this, right? Now in these components, if you see, we need to find which value crosses this low pass filter. So which value crosses? Whatever components which is below 23 Hz. So if you see carefully, see here, the only component which is less than 23 Hz is 13 Hz, right? So the answer is 13 Hz. So let us see another question from Gate 2016. The question is, the Laplace transform of the causal periodic square wave of period t shown in figure below is. So we need to find the Laplace transform of the signal, right? So if you carefully see here, it's a periodic square wave with its minimum value 0 and the maximum value 1, and its period is t, right? So if I have a signal, say f of t, which is a periodic signal, say, so this is a periodic signal, right, and the period is t, then we can see this part is repeating, right, for all period of t. That's what periodic means. So if I take simply this part, that is, say, I will call it as f1 of t. Okay, f1 of t is repeating throughout. Okay, then the Laplace transform of this function f of t is given as the Laplace transform of f1 of t, that is the Laplace transform of this by 1 minus e power minus st, where t is actually the period. So this is actually the Laplace transform of a periodic signal. It has the Laplace transform of f of s is equal to f1 of s by 1 minus e power minus st. So where f1 of s is actually the Laplace transform of f1 of t. Okay. Yeah. So what we need to do, we just need to find what is f1 of s. Okay. So let us take this f1 of t signal. So I will draw it here again. So this is the signal. So 0 to t, t by 2. So this is f1 of t, and I can split this as we can write as u of t. So this is u of t, okay, with the maximum value 1, and this is u of t minus t by 2, u of t minus t by 2, right. So if I subtract this, if I subtract both these two signals, what happens? I will get the above signal, right. If I subtract this portion will be subtracted off from u of t minus u of t minus 2, that is f1 of t. So I can write the f1 of t as u of t minus u of t minus t by 2, right. So what will be f1 of s? If I take the Laplace transform of this, it will be Laplace transform of u of t is 1 by s minus the Laplace transform of u of t minus t by 2 is e power minus st by 2 by s, or I can write as 1 by s into 1 minus e power minus st by 2, right. So what is f of s? The question is to find the f of s. F of s is f1 of s by 1 minus e power minus st. So which means I can write the f of s as f1 of s by 1 minus e power minus st, right. So this is equal to, so f1 of s is this one, so 1 by s into 1 minus e power minus st by 2, which is f1 of s, that by 1 minus e power minus st, right. So here 1 by s, numerator is 1 minus e power minus st by 2, denominator I can split as 1 minus e power minus st by 2 into 1 minus e power minus 1 plus e power minus st by 2, right. It's like a minus b into a plus b, right. This is equal to a square minus b square. So here a is actually equal to 1, so 1, and b is equal to e power minus st by 2. So e power minus st by 2 square means it is e power minus st. So now if you see here, the numerator, these two terms, and denominator, this term can be cancelled. So what is the final answer? This is equal to 1 by 1 plus e power minus st by 2 into s, right. This is f of s. So this is the value of Laplace transform of this periodic signal. So answer is B. F of s equal to 1 by s into 1 plus e power minus st by 2. Yeah, so this is another question from GATE 2016. The question is, consider the signal x of n equal to 6 del of n plus 2 plus 3 del of n plus 1 plus 8 del of n plus 7 del of n minus 1 plus 4 del of n minus 2. If x of e power j omega is the discrete time Fourier transform of x of n, then 1 by pi integral minus pi to pi x of e power j omega sine square 2 omega d omega is equal to. So we need to find what is this value. So the question is related to DTFT, discrete time Fourier transform. So let us first write the inverse DTFT. So it is given as x of n is given as equal to 1 by 2 pi integral minus pi to pi x of e power j omega n d omega, where x of e power j omega is the DTFT of x of n. So let us take this equation and just try to write in this IDFT form. So let us, I will call it as f of n. It is given as 1 by pi integral minus pi to pi x of e power j omega sine square 2 omega. So you know sine square theta is given as 1 minus cos 2 theta by 2, right. So we'll use this relation here. And we will expand this. So x of e power j omega into sine square theta is actually 1 minus cos 2 theta. So 1 minus cos, this is theta is 2 omega, so it will be 4 omega that by 2 d omega, right. So I'll take this 2 outside. So 1 by 2 pi integral minus pi to pi x of e power j omega into 1 minus, again this is cos 4 omega, I can expand in terms of exponential term, right. So I can write as e power j 4 omega plus e power minus j 4 omega by 2 d omega, right, because e power j theta is cos theta plus j sin theta, right. So let me expand this. This will be equal to 1 by 2 pi integral minus pi to pi x of e power j omega. So this is the first term minus 1 by 2 pi integral minus pi to pi x of e power j omega into e power j 4 omega by 2 d omega, minus the third term is 1 by 2 pi integral minus pi to pi x of e power j omega e power minus j 4 omega by 2 d omega. So this is f of n. Okay, now coming to the IDFT form, when n is equal to 0, right? When n equal to 0 in IDFT, okay, we will get this term 1 by 2 pi integral minus pi to pi x of e power j omega e power 0, e power 0 is 1, right, d omega. So this is actually the first term, right? So I can write f of n as first term is x of 0, okay, minus now when IDFT when n equal to 4, what I'll get the second term 1 by 2 pi integral minus pi to pi x of e power j omega e power j omega into 4 d omega, right? So the second term, so this first term, second term is actually x of 4. Similarly, what will be the third term? X of minus 4, right? So this is actually f of n. Now if you see, this is all in terms of x of n, right? And given x of n is this relation, x of n is given as 6 del of n plus 2 plus 3 del of n plus 1 plus 8 del of n plus 7 del of n minus 1 plus 4 del of n minus 2. Okay, so here if you carefully see, x of 0 is when n is equal to 0. So here first term will be 6 del of 2, second term 3 del of 1 plus third term is 8 del of 0 plus 7 del of minus 1 plus 4 del of minus 2. So all these terms, okay, with n not equal to 0, all these term will be equal to 0. Rest the only term which is equal to 1 is del of 0, right? So this term is 8. So x of 0 is actually 8. Similarly, for what all values x of n has any value, whenever this term within the bracket is equal to 0, that happens only when n is equal to minus 2, when n equal to minus 1, n equal to 0, n equal to 1 and n equal to 2, right? While for any other term, that is when x is n is equal to 4, all these terms will be like 0 because none of the term within the bracket is equal to 0. So x of 4 is 0, x of minus 4 is 0. So what is f of n? F of n will be equal to, substituting this will be equal to 8 minus 0 minus 0, that is this is equal to 8. So answer is 8.